Hi and welcome to another Motec webinar. My name's Pete Swinney and today's subject is setting up knock control 2 live engine. If you're watching this webinar, you should have seen the other two already. There is one we did on setup of knock control and just in the software. One previous to this one, which was on a running engine, where we did basically set up the frequency and looked at determining the best center frequency for the engine. And on this final one here, we're just going to look through on a live engine on our M1 Tune software at the retard working and just make sure the system's functioning correctly. So we'll just switch over now to M1 Tune. And you can see we're on again live here, connected, green. And things are pretty much left off from the end of our last webinar. So in the ignition map, we've got a big step in the ignition at full throttle to introduce detonation carefully. And if we go down to our setup of the knock under initial setup to workbook on worksheet 8 knock, you'll see now that from our last webinar we identified that a frequency of around 10k or 10,000 Hertz was the best center frequency to go for. We've now installed that in the knock frequency A parameter, and this is the parameter or the frequency that the ECU uses to do knock control. We've got our basic threshold sorted already, and you will see that running live in a moment. And we've got a 5 degree per second knock recovery rate from any active knock, and we've got a gain of 100%. So for every 10% the signal goes over the threshold, we're going to see 10 degrees of retard. And that retard's going to go up to a limit that we've got specified here. What we might do is we might make that 10. We're coming down around this kind of area, and we'll just make a 10 degree limit. Alright, so if we go back to our knock tuning screen, which was F7 we allocated last webinar. Now that we're done with all this frequency analysis stuff, which is really just a one-off for any given engine, we'll get rid of these just by double clicking them. We're only really interested in the knock on cylinder A, sorry, knock level A on all the cylinders. So that's our 10 kilohertz measurement. Just double clicking these off. Now that's of course not stopping you to log them. You can log all these frequencies, and we might just pop up there and just check that in this file. So edit data logging. Okay, we can just type in knock. Alright, and this particular file we have logged at 100 Hertz, A, B, C and D. We've got all cylinders 1 to 8 and all frequency levels all logged at 100 Hertz, which is going to be fine. And we're logging currently cylinder 1, 2 and 3 and 4 trim levels, which isn't really enough. We need 5 to 8, so I just highlight there by pressing down shift, and we can just drag and drop them in there. We go OK. And all the time while we're doing changes, we need to press Control S for a save to save them to the current file. The ECU automatically updates instantly when you make a change, but if you disconnect from the ECU, shut the key off, pull the Ethernet cable out, you'll lose your changes in the ECU. You'll keep them in the laptop side, provided that you eventually push save, but you'll lose them in the ECU unless you physically force a save. So you can do it. It's not available now because I've just pressed save by clicking here, but laptop based we want to be using shortcuts, so Control S is the two keys to push. So now we've got some basic stuff here. We need to see our trim, or it would be nice to see the trim working when our knock starts exceeding the threshold. So we push C for channels, and we'll just type in knock trim, and we can, if I hold control down, I'll force them onto a new panel, and then double click each one down. Alright, so scaling of 0 to 20. Well, we're only ever going to go to 10, that's our maximum. So if we press, in this case because F5 is allocated to the fuel and ignition screen, Alt F5, can go in here and scale this panel to, might scale it to 12 so we can see what's going on. Okay. Alright, so that's the basic setup. We've got some rudimentary channels here for us to look at. So we'll just make the engine go now, and if our setup's good, we should be able to introduce some knock again carefully, and we should be able to see the knock retard work. Right. Engine's probably a bit cold there now. Just wait for it to get a bit of heat into it. I'll just plug my knock ears in so I can hear what's going on. Alright, so at the moment we're sitting on a nice low part of the map, sitting at 18 degrees. Alright, so we'll just go back to here. Up here you can see I'm just putting my foot down and going into the part of the ignition map with the extra timing in it, and you can see that happening here. But there's not enough cylinder temperature yet to cause any sort of a knock to happen. Let's see if you can just hear that there. Oh, and there's one little ping there. Just let a little bit more heat get into it. Detonation's affected mainly by combustion chamber and piston temperature, so the hotter everything is, the oil, the water temperature, air temperature, that brings the onset of detonation to be more likely. There we go. Couple little rattles there, and I'm just holding my foot flat, and as the knock happens, the retard pulls the timing out and it feeds back in. We'll just push T on that. Just turn everything off. Alright, so we can see that that's working okay. Cancel that out of the way. Double click and drag and zoom in on that. So we can see in this case cylinder 4 went over the threshold being 12, cylinder 4 went to 30, so that's an 18 over, and actually went straight to the limit, of course, because 18 times 100% would be 18 degrees, and just because my logging rate's not that fast, or the update rate on the screen, that would be 10 degrees, so it's immediately gone to the clamp. So that 10 degrees, if the software is working right, we can push tab here and measure that that came all out in 2 seconds. Down here gives you the delta difference between these two cursors here. Just by pressing the space bar, I bring the beginning of the cursor, or the first point of the cursor, and now down here is the delta between the 2 points. So that's 1.97 seconds. If I got it exactly on the 2 points, that would tell me that it would be 2 seconds for our 10 degrees to decay out. So we can see some other little rattles happening there, and also some other individual cylinders just pulling little bits of timing out. So clearly in this case, let me get rid of that delta screen, or delta cursor there, zoom out a little bit, bring it across a little bit. Clearly there's too much timing in this engine. We get a ping on that cylinder It fixes it. Immediately that cylinder gets quieter. You can see here it's fixed within one cycle. The timing starts coming back in, and you can see that cylinder has another go at 7 with the 7 degrees out of it, and there is about 10 or 12 degrees too much timing in that for me to get it to rattle. Comes back down, not long, back at its normal setting, which of course was 32 degrees I think we had in it instead of about 22, and then bang, pings on that cylinder. It's obviously the hottest cylinder, cylinder number 4, and again it goes out. Only this time actually it only went, where are we, our threshold's 12, went 11 over. Alright, so 11 over, calculating around that 9 degree mark. Alright, just because the logging rate's not as, or the screen update rate isn't as fast as the logging rate, you don't get precisely accurate numbers. So because the screen's only updating around 25 Hertz. Alright, so that's the basics of it there. Hopefully that's enough to get you going on how to get knock control started and working. Just take your time, do it carefully. Once you get this set up well, it'll definitely save an engine, and it's really is a very useful tool. What I can suggest is make your ignition retard numbers big. Start with everything really on the conservative side, and then as you get confidence with it on the racetrack or out on daily use, you can start to pull back some of your decay rates. So instead of it all the timing coming out in 2 seconds like here, you can have it come out quite quickly. If it's got the correct fuel for the engine and it's just a little bit of knock, then you're able to get rid of the knock on that cylinder without hardly affecting the power at all by pulling the timing only out for a short amount of time. So by messing with the gain, which is the amount of timing it pulls out for the percent over the knock signal is over the threshold, and the maximum amount of timing that it can pull out, which is the limit, and the decay, which is the speed at which the timing comes back in again. Messing with those 3 main parameters, you can customize the setup of the system to be either super conservative for a road car, say, or very aggressive to just fix knock on a racing car without affecting its power. Alright, and that's it. It's over to you. So good luck, and catch you next time.